Okay, so this video is the second part of the step 2 of the hypothesis testing. In this video, we will show an example on how we can set the decision rule. Now at the same time, I'll also show the first step, or how to write the null and alternative hypothesis in connection to the decision rule. So we'll go through the step number 1 and step number 2 as I explain the example. Let us say the topic is still on the average length of sleep of teenagers aged 15 to 19. Now let's say that the status quo is that the true average length, or the mu, is equal to 7. So the alternative hypothesis that challenges this status quo is that mu is no longer equal to 7, denoting or given that the mu as a symbol is the true average length, or the true population average length of the sleep of the teenagers aged 15 to 19. So how do we proceed to step number 2? Now again, in step number 2, what we need to set here is that we have to determine what alpha to use in the study. So this is your choice. Now let's say that we have decided that the alpha is equal to 1%. Just to be different to the one I used earlier. Let's say alpha is 1%. So that means alpha is 0.01. The rest of the steps will depend on this particular value of alpha. Now the next thing to do is to decide, are we going to use the z or a t-test? Now this decision will depend on the size of your sample size and the population standard deviation. Now obviously, in this study, we have no idea what the population standard deviation is, so we will rely on the sample size. Now, if in your study, you are going to take a sample with a size of 50, then that means this study or this test will follow or will use a z-test. First, because the population standard deviation is not known, so this is not known, but the sample size is higher than 30, and that is, so we were able to determine the z, or the type of test, which is the z-test. The next thing is, are we going to use a one-side or a two-sided z-test? The answer to that will depend on your alternative hypothesis. Now, since the alternative hypothesis is a not equal to statement, then this will require a two-sided z-test. So that means if we create a diagram, the alpha will be divided into two, and one goes to the left and the other goes to the right. So if the alpha is 0.01, because we have set it to be 1%, then alpha over 2, the half of alpha, 0.01, which is 0.005, will be the size of this area, and the other 0.005 will be the region that is located on the right. Again, these regions are what we call the critical region. Now, as you might see in the diagram, there is this number, or two numbers acting as the boundary between the red region and the one with no color. Well, in the screen it is a black area, but it could be a white depending on the paper or the background that you're going to use. So there is a number here that we need to know. Now in my previous diagram, these are denoted as either the z of alpha over 2, or z of alpha, or t of alpha over 2, or t of alpha. Now since we already know that this is a z-test, then this will be a z value. And this is the z of the 0.005. And then this z on the right side is the positive of that number, so z of 0.005. Now these numbers should be known, so that we can easily correlate this with the test statistic that we are going to compute. At this point, I need you to remember the following numbers. This will easily replace the z of a certain alpha or alpha over 2. So referring to the table on the right, the z of 0.005 is 2.58. That means that the numbers that we need are negative 2.58 and positive 2.58. Now, since we are using the z-test for this example, then that means the test statistic that we have to compute will be a z-test statistic. And that will have the formula z is x bar minus the hypothesized mean over the square root of, or the sigma, over the square root of n. And if the sigma is unknown, then we have to place the s instead. Now this z will be a computed number. This is what will set our decision rule. So if we refer to the diagram, the red regions are the critical regions or the area of rejection. So if the value, if this z value will fall on those regions, then we have to reject our null hypothesis. So to state that, if z will be less than negative 2.58, or if the z is higher than 2.58, then the decision is, that is why it's called the decision rule, the decision is to reject the null hypothesis, reject HO. Otherwise, if the number will be in between negative 2.58 and 2.58, then we say that we fail to reject. So otherwise, we fail to reject HO. So that's how we set the decision rule. So again, in step number 2, what we need to do is we need to set our significance level, determine the type of test, and then you set the decision rule. Once you have done these steps, then you are ready to start the data gathering. Okay, so that's all for this video. In the next video, I'll be showing the step number 3 of the hypothesis testing. In that step, it will be shown how you will compute the test statistic, whether for a z-test or for a t-test. Okay?